Okay, we're going to talk about something called crossover and called masking. If you look at this audiogram right now, it looks like in the right ear that the person has essentially normal hearing sensitivity. And if we look at the left ear, this is telling us that this person has about a moderate to moderately severe hearing loss in their left ear. So if you had a patient come in and you had this audiogram and you told them that information, you would be very, very incorrect. What if I told you that really this is the person's hearing loss? They have essentially normal hearing in the right ear, and these are masked symbols for air conduction for the left ear. In reality, this person has a severe to profound deafness. Quite a big difference. A weatherman can be wrong, we cannot. Okay? So what's happened here? Well, if you look at this audiogram, if you'll notice, the left ear takes on almost the same pattern as the right ear. What can happen when you have this much of a difference between the ears is that the good ear will actually cheat for the bad ear. So the signal can actually get loud enough when you're trying to test the bad ear that it crosses through the headphones and is actually heard by the good ear, and the patient will respond. This is called a shadowgram because they look very much alike. And there, of course, is mathematical formulas that we'll need to figure out in order to know what we need to do in order to keep that right ear busy. If we don't do something to keep the right ear busy, we are not going to get accurate results in the poorer ear. So that's why we implement something called masking. Basically what masking is introducing a specific noise into the good ear in order to keep it busy so that the signal cannot cross over to the other ear. In this case, we would use something called narrowband noise, and I can give you an example of what it sounds like. Let me give you one more here. And you'll notice that it changes as frequency changes. So essentially what you do when you do masking is through a mathematical formula, you find out how much noise needs to go into this ear in order to keep it distracted. Okay. You introduce the noise into the ear and repeat your testing. Once you do that, you will find the true thresholds for the poorer ear, where in this case would have been a severe to profound hearing loss. Masking is one of those areas of audiology that even the most experienced audiologists have times when it just gets very blurry to them. This is usually the part that people and students and grad programs really get very nervous about. But just realize why you're doing it. The biggest concern is that you don't want to not give accurate results. We're going to talk about this more in class, but don't get too concerned about it.